In 2015, the movie The Martian swept across the globe, raking in over $600 million at the box office. The scene of Matt Damon living as an old farmer on Mars, growing potatoes, became an instant classic in sci-fi cinema. But have you ever wondered, can we really grow potatoes on Mars? 10 years have passed since then, so exactly how far away are we from actually immigrating to the red planet? To grow a perfect potato, you need air, you need sunlight, you need clean water and nutrient-rich soil, and you need to maintain a suitable temperature at all times. These conditions are very easily met here on Earth, but on Mars, it is a completely different situation. First, let's talk about air. Although Mars, like Earth, has an atmosphere, it is incredibly thin. The density is only about 1.5% of Earth's atmosphere, and the atmospheric pressure is only 600 pascals. That is about 0.6% of Earth's pressure, which is equivalent to the pressure you would feel standing 22 miles above sea level on Earth. The oxygen content in the atmosphere is extremely low. The vast majority is carbon dioxide, accounting for about 95%, while the rest is 3% nitrogen, 1.6% argon, and other trace gases. Furthermore, although the density of the Martian atmosphere is very low, the atmospheric activity is absolutely astonishing. The surface of Mars is constantly ravaged by long-lasting dust storms. And the dust storms on Mars aren't as gentle as a breeze blowing in from the plains. Their maximum wind speeds can reach 400 miles per hour. For context, even a devastating Category 5 hurricane on Earth only packs winds of about 157 miles per hour. When a dust storm hits, it is truly a scene of red sand filling the sky, blotting out the sun completely. These storms can last for a few days at the shortest, or up to several months at the longest. Global dust storms have been eroding the Martian surface for billions of years, scouring out many jagged, slender ridges and layered rocks, creating wind-carved rock formations similar to what we see on Earth. Places like the Badlands of Utah or the wind-eroded landscapes of Arizona are typical examples, and their rock structures are very similar to certain terrains on Mars. However, Mars doesn't have the eerie shrieking sounds you might hear in Earth's wind tunnels. The thin atmosphere of Mars causes sound to travel slower, travel shorter distances, and sound much lower in pitch. Such a thin atmosphere simply cannot allow plants to maintain a normal respiratory cycle, so planting potatoes directly on the surface of Mars is not really feasible. Secondly, there is sunlight. Mars does not have a global, strong magnetic field like Earth does, which means solar winds and cosmic rays can reach the Martian surface directly. Whether for plants or humans, this radiation from the cosmos is harmful. Although Mars is located within the solar system's habitable zone, the solar energy Mars receives is only equivalent to 1/10 of what Earth gets, and even that tiny bit of energy cannot be retained. The thin atmosphere fails completely to form a sufficient greenhouse effect to keep the surface warm, so the temperature difference on the Martian surface is extreme. During the day, under direct sunlight, the surface temperature might reach over 70 degrees Fahrenheit, but at night, it will plummet to around -165 degrees Fahrenheit. This extreme temperature difference isn't just reflected in the change from day to night, but also in the height from the ground. Suppose you stand on the Martian surface during the day. The temperature at your feet might be over 85 degrees, but just by the time you reach head height, the temperature is already dozens of degrees below zero. Your feet are vacationing in Miami, but your head is stuck in freezing Antarctica. If humans don't wear spacesuits, they would lose consciousness in 15 seconds in such an environment, and after 2 to 5 minutes, they would be completely dead. Not even a miracle could bring them back. Speaking of sunlight, there is actually another very interesting little detail. The sunset on Mars isn't orange-yellow like on Earth, but blue. This is a photo of a Martian sunset taken by NASA's Spirit rover in 2005. The cold-colored spot in the picture is the sun, and the sky above it is glowing with a faint blue light carrying a hint of chill. This is because the Martian atmosphere is filled with permanently suspended dust. These floating dust particles of varying sizes reflect different wavelengths of visible light, greatly affecting the color of the sky. Most of the time, the daytime sky appears yellow-brown, dotted with irregularly shaped white patches, just like the scenes in the movies. However, those white patches aren't Martian clouds, but the color reflected by the dust in the atmosphere. But at twilight, the longer wavelength red light in the sunlight is scattered into the sky by the floating dust, so you see the distant sky turning slightly red while the sun itself appears blue. Although the climate environment on Mars is so extreme with low temperatures and wild winds, if we really want to grow potatoes, it's not like there is no way at all. If the conditions don't exist, we create the conditions, just like growing crops on the International Space Station. When the day comes that we truly immigrate to Mars, we can totally build a Mars greenhouse to provide a suitable environment with constant temperature and pressure for the potatoes. Moreover, although the wind speed of Martian dust storms is incredibly fast due to the thin air, the destructive force is not that extreme. It might blow sand and rocks around, but it's unlikely to rip the ground up, so we don't need to worry about buildings being blown apart. If the problems of air and sunlight are solved, what about water? Mars seems to have water, right? Correct. More and more exploration data indicates that today's Mars indeed still preserves a huge amount of water. Although this water is basically all solid ice and most of it is buried beneath the surface. This is a topographic map of Mars, drawn by the laser altimeter on NASA's Mars Global Surveyor orbiter. From this map, we can clearly see that the terrain of the northern and southern hemispheres of Mars has a very distinct difference. The northern hemisphere is mostly vast plains formed by cooling lava, with an area equivalent to the combined area of the Eurasian continent and Oceania, and its geological age is relatively young. The southern hemisphere is ancient highlands with higher elevation, covered densely with impact craters, looking as if it had been blasted in the face by a shotgun. If we were to drain all the liquid water from Earth's surface and draw a global topographic map of Earth as well, we would find that Mars' terrain is very similar to Earth's. Like Earth, Mars has high mountains and canyons, plateaus and basins, and winding river channels with many branches, and both the north and south poles are covered with thick ice caps. It's just that Mars doesn't have active tectonic plate movement like Earth, so the highlands and lowlands on Mars appear in large blocks, whereas Earth's continents are scattered. The reason Mars formed its current terrain is inseparable from its groundwater activity. Don't look at Mars now as a dry and desolate world. In ancient times, Mars might have been a planet with abundant water resources, just like Earth. Scientists speculate that about 5 billion years ago, at least 1/3 of the Martian surface was covered by oceans, and the continental surface was also distributed with a large number of rivers and lakes. With the changes in Mars' climate environment, although a part of the liquid water evaporated and escaped under the erosion of solar winds, a considerable amount of water seeped underground and solidified to be preserved. Previously, scientists thought the main component of the Martian north and south polar ice caps was dry ice, which is solid carbon dioxide. But the latest detection results show that dry ice is only a small part of the ice caps, and there is more massive water ice. For many years, by comparing features with Earth, many scientists believe that the Martian surface looks more like the permafrost regions on Earth, with a large amount of permafrost existing, and water ice exists beneath the surface, widely distributed and rich in content. Moreover, this water ice is only a few yards deep, and much of it is even within a yard of the surface, just inches down, covered only by a thin layer of dust or rock, making extraction very easy. This is an enhanced color cross-section of a Martian cliff, where the blue part is the water ice layer, reaching a depth of over 300 feet with very rich water content. Not only that, after carefully analyzing the latest radar data, scientists have also found many scattered blocks of water ice on the Martian surface. These ice blocks are not small and exist year-round. So far, scientists have discovered subsurface water ice layers in multiple areas on Mars, and even speculate that there are several still unfrozen liquid water lakes beneath the Martian South Polar ice cap. Although, under the roasting of solar winds for billions of years, Mars' water resources are certainly not as abundant as Earth's, and cannot be used directly. With humanity's current technological strength, if we can build greenhouses to plant potatoes on Mars, the collection of water resources will no longer be a problem. Air, water, sunlight, and temperature problems are all solved. So our great potato planting enterprise is only missing one thing: soil. There is an old saying among farmers: face to the soil, back to the sky. But on Mars, this saying would become face to the red soil, back to the sky. This is because the Martian soil contains a large amount of iron oxide, giving the Martian surface an orange-red color. From Earth, Mars is also one of the few celestial bodies in the night sky that glows red. However, the excessively high content of iron oxide makes the solution concentration in the soil higher than the plant cell fluid concentration, causing plants to wither due to water loss. Basically, it would burn the plants. Furthermore, although Martian soil looks no different from Earth's, it is acidic overall and contains a large amount of perchlorates, with concentrations reaching 0.5% to 1.5%. Such high concentrations of perchlorates are harmful to both humans and plants. If we plant potatoes directly in Martian soil without treating the soil to make it harmless, there is a high probability that they won't grow. Even with good luck, if they do grow, their yield and size will be very small, completely failing to reach an edible level. But the good news is, scientists have very perfect solutions for how to eliminate toxic components in Martian soil. Whether it is washing and steaming the soil or using fertilizer to improve soil composition, the methods are abundant and not complicated. When that day comes, fertilizer, even human waste, will become a strategic material on Mars. They will decide whether we can harvest bunches of Martian potatoes. So, although planting potatoes on Mars is still unlikely with current conditions in the not-too-distant future, once humans successfully land on Mars, planting potatoes on Mars will no longer be just a dream. Mars and Earth both have alternating days and nights and rotating seasons. Also, Mars' rotation period is only 24 hours, 37 minutes, and 22 seconds, very close to Earth. So we can totally work at sunrise and rest at sunset, just like on Earth. Imagine, when we stand on Mars, in the distance is the fiery red surface and the blue sunset, while at our feet are crisscrossing field ridges and tender green potato leaves. That scene must be very beautiful. To date, humanity has launched a total of more than 40 Mars probes, from the early Mars 1 and the Mariner 4 to the recent Tianwen-1 and Perseverance. Among them, only about 40% achieved mission success, and the rovers that successfully landed are even fewer. You can imagine the difficulty. Among them, NASA's Opportunity rover is the extraterrestrial rover with the longest working time and the farthest driving distance among all landers. It traveled 28.06 miles in 15 years. Now, there are two rovers still working normally on Mars. One is Curiosity and the other is Perseverance, both from NASA. Curiosity is very hopeful to break Opportunity's record and become the new Mars Marathon champion. Since landing in 2012, Curiosity has traveled over 25 miles, worked for over 13 years, and is still working. The small aircraft carried by Perseverance proved that Martian air can completely support aircraft flight, which provides huge convenience for future Mars exploration and human immigration. In the past few hundred years, humanity's yearning for Mars has never been extinguished. From the invention of the astronomical telescope to the landing of space probes, humanity's understanding of Mars has become more detailed and comprehensive. So, can we actually achieve a manned landing on Mars now? And how far away is the future Mars immigration from us? Since the new millennium, the wave of exploration for Mars immigration has intensified. Not only have governments proposed future Mars immigration concepts, but many space commercial companies and civil organizations have also joined in. The most famous, most radical, but also the most progressive among them is undoubtedly Elon Musk's Mars colonization plan, making humans a multi-planetary species. This was the theme of Musk's speech at the International Astronautical Congress in 2016. In this passionate speech, Musk announced a magnificent and ambitious plan. Within 40 to 100 years, send 100,000 people to Mars, build a self-sufficient Martian city, and the cost of interstellar travel for each person will be controlled within $200,000. By then, people won't have to struggle on Earth to save money for a house, but can choose to use this money to go to distant Mars and start a completely different life. When Musk first proposed this plan, it was undoubtedly questioned widely by scientists and the public, just like when he said he wanted to build Teslas and Falcon rockets. However, as Tesla became the world's most profitable electric car and SpaceX achieved a series of successful space launches, people gradually realized that Musk is serious and has been firmly advancing this plan. To realize this plan, SpaceX specially designed a spacecraft capable of interstellar travel between Mars and Earth's Starship. As the most powerful launch system in human history, Starship's current thrust exceeds 7,500 tons, and its payload capacity to low Earth orbit reaches 150 tons. It can send up to 100 people into space at a time. You know, the thrust of the Saturn V rocket that sent the Apollo spacecraft to the moon was only 3,400 tons, capable of carrying 118 tons. Moreover, the Starship system, including the first stage Super Heavy booster and the second stage Starship spacecraft, is all recoverable and reusable, which means the cost of a single launch will be greatly reduced and the launch interval will be shorter. In addition, Starship also has an expandable version whose payload capacity will be increased again, reaching an astonishing 250 tons. Compared to today's cramped space capsules, Starship's space will be much larger. The interior will be equipped with various perfect living facilities to provide passengers with the most comfortable living space during the months-long space journey. Currently, the total number of annual space launches globally is about 180, but in Musk's vision, a fully mature Starship will have more than 10 launches per day within a launch window. After refueling in Earth orbit, these ships will rush non-stop to Mars and then return to Earth. Musk has said more than once that what he wants to build is not just a spaceship, but a super space fleet. Imagine thousands of starships shuttling through the great interstellar channels like scheduled flights, transporting batch after batch of personnel and supplies between Mars and Earth. How unimaginable that scene is. And Musk's plan is not as sloppy as the previous Dutch Mars 1 project. He has very detailed and seemingly very feasible plans for every stage. According to SpaceX's latest timeline, Starship will officially open its first Mars trip by the end of 2026. The main task is to collect key data on entering Mars orbit and landing on Mars, providing support for subsequent cargo transport and manned landings. By 2028, the number of Starship launches will reach dozens, carrying large amounts of survival supplies, specialized robots, and various modular equipment to Mars. These robots will establish the most basic permanent base on the Martian surface, creating various survival conditions, waiting for the arrival of personnel, and by 2030, Starship will officially open manned missions, successively sending immigrants to Mars. With the help of machines, they will gradually expand and perfect the Mars base, preparing for subsequent immigration and the construction of a Martian city. And Musk's ultimate goal is to send hundreds of thousands of people to Mars within 100 years, realizing large-scale Mars immigration. The Mars Alpha base will be the first permanent settlement established by SpaceX on Mars. From the concept art disclosed by SpaceX, this will be a hemispherical building with a circular base. Sunlight during the day can shine directly into the base through the transparent roof, allowing people to enjoy warm sunlight on Mars, while at night, the lighting equipment on the roof will be turned on, so there is no need to worry about the impact of darkness. Next to the base stand multiple Starship launch pads, and frequent starships will continuously send immigrants and supplies to Mars. On the periphery of the base, large-scale solar panels are laid to supply power to the base. And in order to reduce the impact of Martian dust storms, small nuclear power devices are also essential. The early Alpha base may still need supplies from Earth, but it is the prototype of a future Martian city and an important step towards realizing Mars immigration. Traveling from Earth to Mars takes 6 to 8 months at the fastest, and the communication delay between Mars and Earth is as long as 20 minutes. People on Earth cannot provide rescue in a short time for any emergencies that occur on Mars. Therefore, a mature Mars base must have sufficient risk resistance capability. According to Musk's plan, SpaceX will provide Mars immigrants with the most cutting-edge scientific technology and engineering equipment to develop and utilize Martian resources for power collection, soil improvement, groundwater extraction, etc., gradually developing and strengthening the Martian city, and finally achieving complete self-sufficiency. In a short period of just over 2 years, from April 2023 to now, Starship has conducted 11 launch tests. When many people were still mocking Starship's explosions one after another, Musk was firmly implementing his iterative development plan, improving and perfecting Starship step by step with each experiment. When many people were still questioning that Musk was just a loudmouth or a tech scammer, Starship had already successfully completed a full orbital flight and controlled landing loop on October 13, 2025. Musk once said that he might not see large-scale Mars immigration in his lifetime, but he will still walk down this path unswervingly. Musk's plan may be radical, but he has truly let people see the hope of Mars immigration, no longer just a fantasy in novels and movies. If Musk's Mars immigration is just the frontier of aerospace technology, then the Mars terraforming plan proposed by the famous Mars Society can completely be called the craziest fantasy. The Mars Society gathers the world's most fanatical Mars exploration and immigration enthusiasts. Their goal is not just to build permanent settlements on Mars, but to completely transform Mars into a planet suitable for human habitation through the most radical means over hundreds or even thousands of years. They have even proposed a complete step-by-step process for Mars terraforming. First, by detonating nuclear bombs or guiding asteroid impacts, release all the carbon dioxide buried on the Martian surface to supplement Mars' thin atmosphere. Through the greenhouse effect, raise the temperature of Mars, gradually melting the solid water contained in the north and south polar ice caps and beneath the surface. Afterward, set up a huge magnetic field generator at the Lagrange point between Mars and the Sun to form an artificial protective shield to resist the erosion of the Martian atmosphere by solar winds. Then, improve the composition of Martian soil, transplant Earth plants, and form a complete ecological cycle on Mars. Finally, turn Mars into a second Earth. However, this crazy plan has been ruthlessly refuted by scientists. Leaving aside that melting the Martian ice caps would require at least tens of thousands of maximum yield nuclear bombs, not to mention needing to cover the entire surface of Mars, and the residual nuclear radiation is also a problem. Furthermore, according to scientists' calculations, if we want to release the carbon dioxide on the Martian surface, at least 100 asteroids with a diameter of about 1.5 miles are needed, which is simply a fantasy given humanity's current technological level. Compared to this crazy plan, Musk is at least seriously practicing his grand words, and the research and development of Starship is also proceeding down to Earth. From the current perspective, Starship is very hopeful to become the first manned spacecraft to land on Mars. Perhaps Musk and his SpaceX can really achieve Mars immigration within this century. Of course, governments have not stopped their pace of Mars exploration either. For example, China plans to achieve its first manned Mars landing in the 2030 seconds, and NASA also plans to gradually realize Mars immigration using the Moon as a stepping stone after establishing a lunar base. Currently, NASA has launched a Mars life simulation experiment called CHAPIA. They built a highly realistic Mars base at the Johnson Space Center in Houston to observe the physiological and mental state of humans residing on Mars for a long time. The members participating in the experiment will live in a closed environment within the base for more than a year. During this period, they not only need to maintain normal work and life, but also face various emergencies at any time. And this experiment will also provide very valuable data and experience for future Starship missions that could last 1 or 2 years. Although to date, Starship's technology cannot be called mature, and test launches always cycle between success and failure. However, every progress of Starship will accelerate the pace of the Mars immigration plan. Musk and his SpaceX are also making this vision no longer unreachable through unremitting efforts. Hundreds of years ago, humanity finally confirmed that the Earth revolves around the Sun. Decades ago, humanity left Earth for the first time, set foot in space, and even left footprints on the Moon. Technology never develops linearly. Every technological explosion brings a leap in productivity. Perhaps within 100 years, we can really see the realization of Mars immigration. Just as Musk said, you want to wake up in the morning and think the future is going to be great. That's what being a spacefaring civilization is all about. It's about believing in the future and thinking that the future will be better than the past. I can't think of anything more exciting than going out there and being among the stars. Humanity cannot stay on Earth forever, trapped in the solar system. Our goal is, and always will be, the sea of stars.